the TI calculators have evolved over time, all right? And there's different ways that you can ask your calculator to solve this system of equations. What I'm going to do is call on a function that's built into all the TI calculators. They all have this built-in function called RREF, which stands for reduced row echelon form, which again is a terminology we use in linear algebra. Reduced row echelon form. So if you already know how to solve a system of equations with your calculator, I'm not here to reteach you how to do it. I'm trying to show you a way that works for every one of the TI calculators. That's called reduced row echelon form. Reduced row echelon form. It has to do with what the calculator is going to do. It's going to turn this matrix into something where it's called echelon form, and I mean, it's, yeah. Okay, now, here's where things will be different for every one of you with different TIs. You have to call up the RREF function. And for some people, that's in the math menu. And for some other people, it's in the matrix menu. If you have an older TI, I believe there's a matrix menu, like if you have a TI 83 or 84, it might be a matrix menu. So please go through, see if you can find this RREF function. And if you cannot find it right now, raise your hand and I will come by and help you. If you find it, hit enter, and then you should be sitting at like here's your screen. You should see RREF with the parenthesis. If you're there at the home screen, then just wait. Anybody need help finding it? You're good? Did you do it in pre-cal?
I remember using that for.
Okay, good. So we're good? Everyone's expert here? Okay, so yours has a matrix menu. Yours is different. So you see that yellow? So you have to yellow. Then you have to go to map, then scroll down till you see it. And make sure there's an REF and there's an RREF. Be careful, there's on your calculators there's an REF with one R and there's an RREF, which is the one we want. Okay, you have a matrix menu. See the blue? So you have to hit blue, then go to map, then scroll down. Did you find yours? No?
Yeah.
You got it? Anyone else? All right. So let's go ahead now and have the computer do all the elimination for us. Now look, if you would have done this by hand, you probably would be done already. But trust me, once you learn how to use your calculator, this becomes a lot faster. And if the system is hard, then this way is better. And if you get 4 equations, 4 unknowns, this is the way to go, right? Okay, so this is a computer, right? So you have to type in, I almost said a bad word. You have to type in your stuff properly, or else it'll be a syntax error. So the first thing it wants is for you to let it know you're about to start putting in the matrix. And that's what the first bracket represents. And that's what it says on your little cheat sheet. I told you what each of the little symbols is there for.
We can have this on the test?
No. You shouldn't need it. You can learn it. It's pretty quick. You can pick it up.
So you said the bracket?
Okay, so a bracket. Now don't put a brace and don't put a parenthesis. I had students putting in the brace. It's not the brace. It's not a parenthesis. It's a bracket. Okay, and I believe it's over there. Well, again, it depends on the calculator. It's in different places.
3 equations, 3 unknowns will for sure be on the test.
3 equations, 3 unknowns will for sure be on the test. I don't know. I haven't made the test. There's a good chance. Yeah. All right. Well, no. Again, don't go buy a calculator. Don't be. That's what I don't want you leaving here. Say, well, I got to go buy a calculator for a test. You don't know anyone who has one that you can borrow for a while? Try and find. Try and find one. I have like 3 or 4 of them just sitting in my office, and I'm willing to loan them out for the remainder of the term for a small price. Okay, start the matrix, right? Start the matrix. The next bracket tells the computer, here's the first row. And then what you're going to do is you're going to type in the first row of numbers, which is representing your first equation, and you must have commas between the numbers. So make sure you can find your comma key also. What? Okay, let me give you an equation. Let me give you 5 equations and 5 unknowns. You'll have a different idea about that. All right, so this good? Now the bracket here ends the first row. start the next row. 3, comma, 2, comma, negative 1, comma, 2. Close it, ends the first row, or second row. Third row, third equation, negative 2, comma, 0, comma, 0, comma, negative 1. Close, which means you end the third equation. Another close bracket, which ends the matrix. You might be saying, well, wait a minute, why do you need to start a matrix and end a matrix? Doesn't it know you're putting in a matrix? Well, you could theoretically have two matrices in here that you maybe are like multiplying them together and then taking the RREF. So, you know, the computer is more powerful than you need it to be, I guess. Then you need a parenthesis, which, you know, that's the same reason when you write something like sine of 2x plus 1, you don't just stop there, right? Like, you have to close off the function. So closing off the function RREF, enter. And now once you hit enter, you should see something like this. You should see 1, 0, 0, 0, 1, 0, 0, 0, 1, and then the right side, there's going to be a list of numbers. So did you get, yours is fancy enough, did it leave it as a fraction?
Yeah.
Yeah, so depending on the fanciness of your calculator, it might give you a decimal or a fraction. Most of them will be decimals.
So, like, if I type that into Wolfram Alpha, would it do the same thing as...
Well, how do you type that into Wolfram Alpha? I don't believe Wolfram Alpha has that built-in function. Or it does, I mean, Wolfram Alpha obviously can do this, but it doesn't use a function called RREF. So if you type that in, I doubt it would know what you're wanting it to do. RREF is specific to the TI. It's the language that they use, okay? In Wolfram Alpha, you could probably put solve, just write in solve, and then type in your 3 equations. But you can't use Wolfram Alpha on the test, so. Okay, what here now?
1/5.
1/5, so that's 0.2. And then the last one, negative 0.1. So that's what you would get. Now let's just real quick interpret what this means. If we go back and I ask you to take this and turn this back into a system of equations. Remember, this was the coefficient on A, on B, on C, and then equals this, right? So wouldn't this be saying 1A equals 0.5? And wouldn't the next one be saying 0 here, right? That would be, what, 1B or just B, right? Do I need to write the 1? No. B is equal to 0.2, and then the last one would be C is negative 0.1. So this form that you see here, 1, 0, 0, 0, 1, 0, 0, 0, 1, that's the echelon form that we're talking about. And the computer did all that for you. All right? Now, you would also want to try and convert these to fractions. And since we all know that this right here, 0.5 means 5/10, right? 5/10. That's a half. And this means 2/10, which is a fifth. And this one means negative 1/10, which is negative 1/10. Does anyone have the TI 89? No? Did it give you fractions or decimals? It gave you fractions. And then you have the Nspire. So that one also gives you fractions. So you pay a little more money and it'll leave them as fractions. If you got the 84, yeah, if you do the 84, then you know the 84 is probably going to give you decimals, right? But I believe on the 84 there's a way to convert from decimals to fractions. So I mean there still is a way to get your answer. So it's not a big deal. All right, we good? All right. Theoretically, you can solve as many systems of equations, you know, with that RREF, you could do 30 equations, 30 unknowns. Theoretically, if you could just type everything in correctly. Back to the problem. I know this does seem like the long method, I agree, but it's because I had to show you how to do it first, all right? So here's where we were. We were at integral. We had x squared plus 2x minus 1 over, we had factored that, was it minus 1, x plus 2? Okay, that's where we were. But then we were able to break this into 3 fractions, one with the x on the bottom, one with the 2x minus 1 on the bottom, and another one with the x plus 2 on the bottom. And the numbers on top, a, b, and c, we just found, right? A was 1/2, and then b was 1/5, and c was negative 1/10. And then go back and look at your notes from last class. We got to that place also, didn't we? The short method. So you should be able to follow your notes from last class to write the answer out. Questions? We're good? All right, so we're going to say we're done with this. Here's our next problem. So what are you thinking here? Long division first? Yep, long division first. So let's do our long division. X to the 4th plus 0x cubed. Remember to leave yourself that space there. Right, for the x cubed term, since there isn't one in the numerator, I'm going to leave a 0x cubed there. And then on the outside is the x cubed minus x squared minus x plus 1. And I get to play that game where I try and turn my thing out here into this, right? So what do I need to multiply by x, right? And it doesn't matter where you put it. I'm just going to put it here. So then I do x times each one of these, right? And then I put those underneath their appropriate column. So x times x cubed is x to the 4th. I put it here. X times negative x squared is negative x cubed. I put it here. X times negative x is negative x squared. And x times 1 is x, so here. Then I come through and subtract. So when I subtract, everything's, the signs change on everything. So if it was positive, it becomes negative. It was negative, it becomes positive. Negative becomes positive. That positive becomes a negative. Then you add down. What do we have? Gone. We have just an x cubed here. Minus x squared. Plus 3x. Plus 1. And then we play again. What do you multiply x cubed by to get x cubed? 1. So plus 1. And then 1 over change. And add down. What happens when we add down here? 4x. Just 4x. That's all that's left. And can we turn x cubed into 4x? No. So we put up here plus 4x over x cubed minus x squared minus x plus 1. Were we kidding around last class about like putting r? Yeah. Did we joke around about that, like r? Right? Yeah. It's kind of funny because yesterday I picked up my daughter from school. She's 7 years old. And she's like, she's a really good student. I don't push her. She's just like one of those kids that's like determined to like do perfect on everything, like cries when they fail at something. She's one of those kids. So like, she's like, today, Daddy, I did the hardest thing ever. I was like, okay, what did you do? She said, we did division. And she said, we did like 15 divided by, I forget what she said. It was like 15 divided by 6. And I was like, okay, so you had an R, right? And she's like, yes, I had an R. And she was like all upset about that R. And I just thought it was funny because we had just talked about that the other day, how we don't do that anymore. Yeah, we do that in 2nd grade, right? We don't do that here. We actually need to write the remainder over the divisor, right? Yeah, it'd be nice if we could just stay back there and just R. All right, so now what we do is we rewrite the integral, right? We rewrite the whole integral.
I heard they're doing it again.
Here it comes. The new integral is equal to x plus 1 plus 4x over x cubed minus x squared minus x plus 1 dx. And what's good about that? It's easy what? What's easy about it? I agree something's easy. It's not all easy though.
There's no.
Yeah, you can split this up into separate integrals. So those first two are going to be easy to do, right? Antiderivative of x, done. Right, so the first two are good. I'm going to actually write those down. We have 1/2 x squared, and then we have plus x. But then we have this integral, which we were not able to just look at and do. Right? And then we say, all right, now we need to handle this. I've done the first step, which is long division. When I look at that, I still have a rational function, don't I? But the denominator's degree is now bigger than the numerator. And there's no simple thing that I see here. There's no like basic U substitution or trig substitution or anything that we've learned. So I'm going to just go with partial fractions. And that means I need to factor the denominator, right? Okay. And so let's just remember that first part. I'll come back to it. I'm going to just erase everything and work solely on this piece right here. All right, so this is now my new little universe that I live in. I just want that integral. Let's work on the factoring. I'm going to do the factoring over here. X cubed minus x squared minus x plus 1. Can you factor that?
Yes.
Okay, how? Can you factor that?
Well, you'd have to
Split it up?
Yeah.
Why are you splitting it? Because that's right, but it's 4 terms. That's when you do it, right? When you see 4 terms, your technique is usually, well, you always go GCF first. Is there a greatest common factor? Which there is no greatest common factor. But because I have 4 terms, I'm going to split this. This method is called grouping, factoring by grouping. And if you don't know what I'm talking about, then you'll need to YouTube that or go back to your old notes. Okay? Grouping works by splitting it up and factoring first the first 2. Pull a GCF out of these. X squared. What's still left in the first 2? X minus 1. Now for grouping to work, you need to be able to have an x minus 1 over here also. So I take a negative 1 out of both of these, and I'll be left with x minus 1. Once you're here, if these two match, which they do, then your answer is just x minus 1, what matches, right? And then times what here? X squared minus 1, which is basically the coefficients out. You could write this the other way. You could write x squared minus 1 in front of x minus 1. Is that the way you learned it? Yes? This always troubles me. This part right here always troubles me.
Why do you just drop the x1? Why do you just drop it? Just because?
Well, the reason why this troubles me is because the way people learn it, they aren't actually taught to think at all about what the hell just happened. Oh, hell's okay. They say that on the radio all the time. I hear it in songs all the time.
Why did you
I think
stop?
we need, because at first I thought I was going to say something else.
You knew you should.
It really, okay, so it troubles me that
Yeah, I'm looking at.
that people do this and don't know, like, they know what to write, but they, like, you know, you were saying, could I do this, right? Because this is the way you were taught. Like, that's better for you because that's the way you were taught, right?
So I think about like your next step. Will it make a difference? That's what I was.
It won't make a difference, no. My big question is, why does this become this,
Yeah, that's what I'm wondering.
right?
Me too.
Okay. So let me ask you this. If I wrote this down,